Yes, we've got 3 presentations coming up, but before we start on that, first thing to do is I'll stick the agenda in the chat so you can follow. Would like to kind of flag the heat and retrofit coordinator role, which has gone live, and that's going to be supporting the Rosendale project. And so I'll put the link to that in the chat, but please do share among your groups and with people who might be good for the role. Really keen to get a strong group of applicants for it. So yeah, please have a read through and share with your networks. I don't think we've got any actions from last week to cover, but please do shout if anyone disagrees. So I'll open up to updates from the group, and please bear in mind, obviously there is a lead projects group later today, so if you've got anything to do with that, save it for them. But has anyone else got another update they'd like to share with the group before we start on presentations? No? Okay. So straight on to presentations then. I think the first one we have is a kind of presentation on Swaffham Prior. So who is it that's leading on that?
That's me. It's not Swaffham Prior. It's about the challenges of trying to replicate Swaffham Prior in other similar areas.
Okay, fantastic. Thanks, Sandy. Are you able to share screen, or do I need to?
Yeah, give me 2 seconds while I just find the right one to share. The question is, can you see that?
Yeah, that's going through well.
Brilliant. I'll just do a quick check to see that you can see the slides moving. Does that work?
Yeah.
Yep. Okay, brilliant. Fine. So I think I've got 10 minutes. I will try and be as quick as I can with this. There is so much I could cover and talk about on this project. Some of you may already know of it. But very quickly, myself, I am Sandy Robinson from SEEN. We are community energy consultants, so we work with communities all around the UK on everything from carbon auditing to developing wind turbines and solar to heat network projects. Very varied, but we've been doing this since 2011, and I know quite a few people in the room, so hello to those I do know. What I'm going to talk about today is a project that we worked on with the community of Upper Heyford in Oxfordshire, particularly a group called Heat Upper Heyford, who are a subset of the parish council. They wanted to take forward a heat network project inspired by Swaffham Prior, as many have been, and they were funded through the Rural Community Energy Fund. So I'll give you a brief overview of the project, very brief. I obviously can take questions at the end, but what I really want to focus on is the challenges, the reasons the project is not progressing at the moment, and the reasons for those who have been involved in heat projects, particularly heat network projects, will be all too familiar with. So as I said, a quick overview, a little bit of the technical basics. I won't go too technical, but for those who are interested, I'm very happy to chat afterwards or via another meeting should they want to talk it through. And then I'll go into the crux of this, which is the barriers to development, how we're seeking to overcome the various challenges that we've come across, and where we go from here. So the project itself was funded in 2021 under the Rural Community Energy Fund to conduct a feasibility study, which was not done by ourselves, but did recommend that a heat network project was viable for the village of Upper Heyford. I'll tell you a little bit more about the village in a second. We picked up the project in 2022 with Rural Community Energy Fund second stage funding, which is the detailed design, the development of a business case, the testing of the thermal resource, all the more detailed parts of the project, trying to get us to the point of, we're trying to get the project to the point of investment, essentially. December 22, we did an energy baselining study. So there'd been a desktop study done at the feasibility stage, and we went around and surveyed and talked to community members and gathered that information. May 23, we drilled a 200-meter hole in the ground to test the ground source potential. So we're looking at the thermal resource from a particular piece of land next to the village. And from there, in theory, everything goes smoothly and you come up with a nice business case and you get funding through the UK government's Green Heat Network Fund, and you find separate investors and you gather support from those who you need it from, like the local authority and so forth. But we couldn't put together a viable business case. We couldn't put together a financial model that worked, which is what I'm going to talk to. So at the moment, we're sitting in kind of no man's land. We have a community event happening in June to talk through the project and where we go next. And we will be submitting a planning application later this year to try and lock in some parts of this project. So here is a very quick overview. This is not the correct graphic, but this is one of our planning graphics, but it shows you the network extent. So we've got about 150 properties. The green area over on the right is the energy center location. The blue area is where the borehole array would be. And the red area is the planning outline, but it's also where the pipe route would go around the village and to the properties. Little bit on technical design. So this is where we ended up on technical design, which was a long and quite challenging process, with a 400 kilowatts being supplied by ground source heat pumps from just under 200 boreholes, and then a total of 800 kilowatts coming from air source heat pump units. This is a simplified design, but we went through the very kind of detailed design process to try and get to this, and this took a lot of time, a lot of testing of the technical and financial variables to come to this point. So a few pictures just to make it real what we're talking about here. Energy centre site on a piece of land that's owned by the parish council and is currently tenanted by, has a tenant farmer. The borehole site is right next to that. In fact, on this borehole site, you can just see the sheds in the back there where we would have our energy centre. One of our big issues is the aging electricity grid, which I'll talk about in a little while, one of our technical challenges. And then there you can see our thermal testing rig, which was sat there for a few days testing the thermal resource from our borehole site. So that's the very quick overview. I hope that's not too fast. I'm sure there are questions, but I'm going to run through where we ended up in terms of challenges. So we had a few technical challenges. These are probably, if we're talking in the context of the Swaffham Prior scheme, fairly consistent, at least the low heat density of a heat network in a location like this. So we're talking about quite separated properties. It's quite a long settlement. A lot of pipe work is needed to reach these settlements, and there's thermal losses where those pipes go. So the longer the pipes are and the further away things are, the less suited to heat networks we are. This is within the Rural Community Energy Fund program, so these are generally rural projects. So there's this kind of underlying question about the suitability of heat networks in rural contexts. It's definitely doable, but it takes a certain set of conditions. So that's one of the challenges that we battled with throughout. I think any rural project would. Our thermal resource test returned poorer results than we were expecting. So we were working on the basis of the initial consultants, kind of, I think 4.5 or 4.5 COP. So for those in the know, so those not in the know, that's coefficient of performance. So that's how efficient the heat pumps would be, and based on the thermal resource that we can pull from the ground. That really hits our financial model. It hits the technical viability of the scheme. And yeah, it's a real challenge. And we spent quite a lot of time talking to those at Swaffham Prior to try and figure out why ours is low, how theirs differs, what is so different about our underlying geology that led us to return these values. So that was another challenge. The aging grid infrastructure I've talked about. There's grid upgrade plans in the area, but basically we were told we wouldn't be able to connect the energy center for a few years. And we wanted to look at cogeneration, so things like solar PV or even wind turbines to supply our site. And that's effectively a no at the moment. And then lastly, one of the probably consistent things with Swaffham Prior and with other rural heat networks is a very complex and I say historic housing stock. I mean, often listed protected buildings. The conservation area itself in the village also limits us. So we ended up with a high temperature design, so supplying high temperatures to properties to reduce the need for energy efficiency works. That's because a few things. A, the cost of works. A lot of the properties were quite large and it would need significant updating in terms of energy efficiency measures. A lack of support and interest locally. People did not want to have to change the look of their house. They did not want to have to be dealing with the disruption of insulation works, that kind of thing. And the last is the consenting process. So for those listed properties or for the conservation area, any kind of external works were challenging, to say the least. So one of the rationales that led us to a high temperature network design. This is a bit about the social challenges. I won't go into too much detail here, but this is about how you secure sign up. Modeling a heat network like this, we started with 100% sign up rate, which frankly is not something you're going to achieve in your first round of build out. Swaffham Prior, for example, is doing it in a phased way where those interested are allowed to connect. We found that those who are interested were kind of spread geographically around the village, and it really impacted on things because you could have 5 interested people on one side, 5 interested on the other, and nothing in between. It meant that the cost of connecting customers didn't make sense for the amount of heat we were supplying and the revenues we could generate. So it was about trying to figure out how to model lower than 100% in a rational way. Not just saying, oh, if 50% of people connect, this is what it looks like, because we need to know where those 50% of people are in the village. What is their location? What is their heat demand, etc. And the last point here is just about legal staging. So all well and good, have a community meeting, get some initial interest. You might get 50% of the village interested in the project. You might get a really high percentage interested. You might want to secure a letter of intent, something to say we would like to go ahead with this should it happen. And that, it's low commitment. It's there's not much risk of doing so, and that's something that we got from a reasonable proportion of the village. When it starts getting more legal and you start getting kind of heads of terms, which often you can draft to not be binding, but it becomes more risky for the customer. They're going to step back and say, hang on, I'm not going to do anything until this is, finally designed and financed. Securing finance, though, requires you to have an understanding of your customer base. So there's this real chicken and egg thing that's really hard to negotiate, to cross that boundary from the kind of non-binding commitments to the more binding. And finally, heat supply agreements, which would typically be signed at the point of build out. So we obviously have not got to that point. One interesting thing, and maybe worth talking about, is that we engaged with the community and had some really good discussions demonstrating this process and showing them what heads of terms and heat supply agreements look like. And the feedback was generally quite positive, and providing that information earlier in the project did give us a kind of a lot of really useful feedback and helped develop people's understanding of what they were potentially buying in or signing into. So that was our social barriers. And then the key thing, the financial barriers. So we couldn't make this work financially. The crux of this is the fact that people are on oil and gas. They're paying 5, 6, 7p per kilowatt hour. And we were looking at electricity tariffs of 30, 34p, which meant we needed COP, so coefficient of performance again, of 4.8, which is extremely high for a ground source scheme, extremely high for a ground source air source hybrid scheme as we were looking at, and it's just not achievable. The other thing that we struggled with is forward projection. So anyone has a great source out there on the future of energy prices, I'd love to hear about it, because right now it's unbelievably hard to know what's going to happening with electricity prices, with fossil fuel prices, and so forth, which makes the projections required for projects like this, 40, 60-year projections, really, really challenging. Even a 5-year projection is not an easy thing to establish. There are means and ways of doing so, but the risk is high. We struggled with our high operating costs. It's due to the high temperature designs that we went for and the electricity prices that I've talked about. But basically, those operational costs were far in excess of the baseline and the what's called the low carbon counterfactual, so air source counterfactual. And yeah, the argument basically wasn't there from a financial perspective. High capex, we're looking at around 10 million for this. Is 10 million a reasonable amount to be developing heating system for 150 properties? It's not. That is a genuine question. I'll get to the impact of this in terms of carbon, but it is a high cost and a high amount of money to be trying to raise, particularly for what is a high risk project. So my point 5 there is from talking to both local authorities and potential investors and the heat network delivery unit, the perceived risks on projects like this are really high. They're high for heat networks, but they're even higher for community heat networks. So the rates of finance we were being effectively quoted were extremely high. We're talking 9, 10, 11%, and they were further compounding our issues with financial viability. And governance, always an issue when you're talking community schemes. The resource on community resourcing community groups and the expertise within community groups, some are really well placed, but when we're talking about a village with a few committed individuals who aren't energy experts, who may not have the time to take on projects, then we need to have a reasonable approach to governance. We had interest from the district and county council, but in nowhere near the kind of level of commitment that we would hope they'd be able to make to help develop the project. So that's a real stumbling block as well. How am I doing for time? Am I going to run massively over here?
Yeah, we need to be wrapping up a little bit shortly so we can get time for questions, but yeah, you've got a little bit longer. Okay, fine. So I think I've only got a couple of slides left, but the key messages here are really around the choice of design. Our high inlet temperatures and the requirements for our scheme were designed to reduce energy efficiency needs, the cost of energy efficiency, the disruption of energy efficiency. And that was consistent with what people in the local area and the village wanted. But that really increases our operating costs, and the operating costs are what are killing the project. We did a lot of scenario testing to see what we could make work here, and that's how we ended up in looking at different types of design, which I'll talk about in a second. High capex costs, and the large margin between our fossil fuel and electricity prices, as I mentioned. You just can't provide a cost competitive tariff to the end user. We're talking about, a marginal scheme, so a scheme that's not returning huge amounts to investor. It's meeting our investor needs in terms of 5 to 7% return, but we're looking at 18p a kilowatt hour for customers. Now, if you're an electricity customer, that's a significant electricity user, sorry, for your heating. That's a significant drop. But if you're talking about someone coming from gas at 7 pence per kilowatt, it's a hard argument to tell them you're going to be paying 18 on the heat network. Investments, a huge challenge. Talking to the HNDU about the Green Heat Network Fund, the sense that we have got is that larger infrastructural projects are more of a focus. Urban projects are more of a focus, with heat network zoning
Upper Heyford is going to fall out with the heat network zones, the chance of this project getting funded through that route is low. And without that 50% capex fund, we're going to massively struggle to raise finance for this. The only positive, well, not the only positive, but one of the major positives of the project is the carbon savings. And it's really important to stress this, that this was a rationale for the project to start. And they're far greater than both the business as usual, so the gas and oil situation currently, and the counterfactual, so everyone slowly moving on to air source heat pumps. And that also accounts that also, you know, that impact would happen sooner. So it forces a quicker transition with the heat network. Everyone in theory is moving over around the same time, rather than something like an air source heat pump transition where people may take 10 plus years to decarbonize, or at least move to electricity, should I say. So the carbon impact is huge, and that's something that, you know, it's a rationale for delivering a project like this. So lastly, what have we been trying to do? We've been trying to reduce our energy costs, looking at solar and wind, reducing the capex through looking at lower temperatures, trying to stay within the bounds of not forcing too much of an energy efficiency upgrade in the local area. So looking at maybe 60 degrees rather than 75, that kind of thing. We're investigating alternative technical solutions. So we looked at air source heat pump only systems, gas hybrids, which goes in the face of our carbon goals, but it does improve the viability. Reducing the network extent, so looking at particular areas for small shared loop systems, and identifying our target variables. And this is quite an interesting one, and maybe something we should have done earlier, is looking at what should our capex be? You know, how far, what's the limit we can go in terms of spend? Well, you know, what's our fuel price target? What do we need electricity prices to be? What if gas prices increase dramatically? How does that affect things? And then the rates of finance we would need. So very, very quickly, our next steps, we're talking to the community in June, submitting planning in July, and that's trying to de-risk the project a bit, trying to secure something concrete to help us take forward in future years. Looking at funding for supporting projects, energy efficiency works that people want to do, air source heat pump rollout potentially. Continuing to talk to funders, but it's a bit of a tough one because, well, we don't have a viable business model right now. And lastly, looking at electricity supply opportunities with nearby housing estates. So with the grid limitations, everyone in the area is trying to make local supply work, battery storage work. So we're trying to kind of jump on other projects nearby to supply our system. So sorry if I went over, and thank you everyone for listening. I hope it wasn't too overly technical or too in depth, and I hope that things were clear. I see a lot of questions popping up. Thank you.
Thanks very much, Sandy. That's really, really interesting. Really appreciate it. We have a very short amount of time for questions. So what I'm going to say is I'm going to do 5 minutes of question time, followed by Sandy, please keep an eye on the chat for the rest of it. And if people have questions they want Sandy to answer there, please draw attention to it in the chat. Derek, you're first up with your hand up.
Hi, Sandy. Really interesting presentation. Thank you for that. What you've just described is essentially what we've discovered in Chipping in Lancashire. Exactly the same issues, slightly larger rural village, different geography, but essentially the same issues. And we were also involved in the development of Swaffham Prior, so we also had some physical learning in terms of the consenting challenges you talked about for Swaffham Prior. We've developed a clustered ambient approach in Chipping. We've just submitted planning for our first pilot scheme for Chipping, which we think is doable, although it remains extremely challenging in these dispersed rural areas. But I'd love the opportunity to sit down and maybe talk through that approach and how that could be replicated in this instance. In terms of some of the wider challenges you mentioned, what we discovered around the Green Heat Network Fund was that you're not only dealing with the 50% capex issue, but actually you're dealing with a competitive environment, and they prioritize projects that can deliver heat at a lower cost per kilowatt hour. So effectively, unless you're in the 20 pence a kilowatt hour, the 2 pence 2 to 2.5 pence per kilowatt hour, you stand a very low chance of securing green heat network funding. But certainly there is some great opportunities, I think, for some shared learning here, and I'd love the opportunity to pick up with you outside of this environment if that's possible.
Yes, definitely. I'll drop my email address into the chat. And yeah, on the ambient systems, we did look at this initially, the high temperature route. I talked about why we went for it, but we've also looked at this on the island of Iona. So very different context, but we looked at ambient loops there, and that project very nearly went ahead and is still in the works. But yeah, so we know a reasonable amount about the ambient approach, but yeah, it was kind of pushed away from by the community, and actually, to be honest, our own technical designs initially. But yeah, very happy to chat about that. So I'll put my email in the chat.
I look forward to that. Thanks, Sandy.
Helen, excellent.
That was a brilliant presentation. So BESCO has done 3 similar projects in rural settings. One, we just looked at all different kinds of technologies on a heat network, including water source heat pumps on an ambient loop, very similar. And every time we came to the same exact conclusions that Sandy has just demonstrated in his. And so I would say, as this appears to be our mutual experience, that considering doing heat networks in rural communities where you don't have that density of heat loads is probably not possible. We're now looking at blocks of flats in urban environments. And even then, we're seeing that because of the differential between gas and electricity prices right now on the market, it's very difficult for us to put together what might be an attractive heat price for residents. And so we're almost in the place now where we're not going to apply for Green Heat Network Fund, even though we have 2 exquisite urban blocks, many blocks. So we have the heat required in these networks. We're not going to apply because we don't think that we can make it with the current differential between gas and electricity prices, and we absolutely need that gap to start closing before these projects become financially and economically viable.
Yeah, I would just agree with that. One thing I'd quickly say is that, there's looking at Swaffham Prior, the 2 things that helped them were the renewable heat incentive. So, having subsidized tariffs is a lot better than capital funding in most cases, to be honest. The other thing is that they have electricity supply. And having looked at projects in urban situations, so heat from parks and that kind of thing, including in London and so forth, we've had to try and specify things like rooftop solar to make them vaguely competitive, but it's a huge challenge.
Thank you very much, Sandy. Thank you very much for the question. Please keep them coming in the chat, Sandy, to pick up, and offline after this meeting. Obviously, really interesting so far, but I have to move on to the next presentation now.
Sure.
So Ben, got 10 minutes of presentation and 5 minutes questions on that, if that's okay.
Sure. Okay, I'll just share my screen. Is that working?
Yeah.
Okay. Hi, so my name is Ben Cannell. I work at Share Energy. For those who don't know, Share Energy support community energy groups to develop and operate community energy projects. We also have a kind of spin-off, which is Big Solar Co-op, which is installing solar on large rooftops. Yeah, I'm here to talk today about a community heat development unit project, which we started last autumn. This project has got funding from the Ofgem Energy Redress Fund, and essentially we're trying to take steps towards enabling communities to get community-owned heat networks built to try and get citizen and community representation in heat networks. I guess the background behind it has come from kind of the story that Sandy was telling, and what seems to be the story from many community heat network projects which have been assessed and attempted, is that then the locations which communities want to get heat networks developed aren't necessarily the locations which are best suited to heat networks as a form of low carbon heating, or as being something which is financially viable. And so the aim of this project is to take a different approach. So we're taking the approach where we're going to try and identify locations where community-owned heat networks would be viable, and then try and stimulate those and seed those projects to be developed in those communities, and also look at what would need to be set up, what community heat development unit would be set up to support those communities, either in the development or the operation of those heat networks. So so there's three main steps on the screen. So firstly, we want to develop an engineering and financial specification of a community-owned heat network. So kind of what is the configuration at a location for a community heat network to be feasible. Then we want to identify where that specification can be replicated in different locations across the country, and try and get some case studies developed in those locations. And then off the back of that and kind of the learning from that, develop a business plan for this community heat development unit to understand what additional support communities need to actually get the heat networks developed and operating. And we're working with Community Energy England on this, help with the community engagement and outreach side of things, and then also the Marches Energy Agency, who'll help us on the modelling and costing of building retrofit for like improving thermal insulation and heat emitters, etc. So yeah, in terms of progress so far we've mostly focused on research. So looking around to see what low carbon heat network projects have been developed so far, ideally ones which were operational, and then so we've looked at the UK and then some cases abroad, and we've also spent time looking at the different feasibility studies which are available, which have been led by communities. I guess we're trying to take learning from these into our model, to try and shortcut some of the steps in the analysis process. I've got some icons to do like general things which we've taken from this research, and so heat networks the community-led heat networks which have predicted the greatest kind of financial viability seem to have the largest anchor loads in the network, and so maybe that's communal housing or some larger public buildings such as leisure centres. Inclusion of renewables in an electrified centralised district heat network always seems to be predicted as improving the project finances. So it seems like that's an important aspect to be able to configure with a heat network. Targeting 90% carbon emissions, or 90% of your heat demand using electrified means, and still accepting that you're going to have 10%, say, of your heat delivered by a higher carbon means to start off with, really does improve the project finances from the studies which we've reviewed. So it seems like target 90% electrification, don't go straight onto 100% start off with. That 10% can always be electrified further down the line. Also, yeah, we've reviewed different kinds of heating technologies which you'd want to include in the heat network. Seems like mine water seems like a great resource to be used, and has good correlation with kind of high density housing. From our perspective, we're trying to come up with a configuration which is most replicable across the country, and it seems like site to site variation potentially significant, and so there's quite a high risk with replicating a consistent model across the UK for mine water. So that's one of the technologies which we've decided to avoid moving forward for this first instance. We've also been on a couple of site visits to actually visit real operational heat networks. So one was in Rocks Green, which is in Ludlow in South Shropshire. So they've got a biomass heat network which is connected to 96 houses. And then we're working closely with the Bishop's Castle project, which is in South Shropshire again, which is looking to have a heat network powered by centralized heat network powered by a large air source heat pump, combined with a onshore wind turbine. We've been working closely with the project team there. It's Shropshire and Telford Community Energy and Lightfoot, which are the community groups which are leading that project. And yeah, good news recently in that they received the award of the second stage of CEF funding, which is great news. So the next stage that we're working on at the moment is kind of the development of our heat network specification. So what configuration of heat network are we going to be targeting is viable for community ownership. So we're developing a techno-economic model, and we're hoping to work with a kind of engineering focused technical partner on this, where we're saying, let's say if we want to understand what kind of heat demand, what ranges of heat demand do we look for across the country, with what kind of, coupled with a kind of building density, and also coupled with what level of renewable generation capacity. So what different ranges of those different input values would mean that from a modelling perspective, we think that a community-owned heat network is financially viable. And so, yeah, once we've developed this specification, we're then going to use the GIS sieve mapping approach, where we are applying those ranges of variables to a nationwide site search. So we can select sites across the country which we think meet this heat network specification. So yeah, once we've identified these sites, we'll then be working with Community Energy England to approach community ambassadors, leaders, community groups within these locations to try and stimulate enthusiasm and uptake for pursuing the development of a heat network in these locations. So we want to seed up to 4 case studies in these locations, so we have a more detailed kind of like feasibility study, lightweight feasibility study assessment of the heat network configuration at these individual locations. So we don't have funding to take the project further than that at this stage, and we also want to that stage might involve some refinement to our heat network specifications. So maybe we'll go from saying we're looking at these ranges of heat density and building count to saying something like we're looking for a certain number of terrace houses, a certain number of communally heated buildings, and a leisure centre, something more specific perhaps, which we're looking for across the country. And yeah, as part of that also, MEA will be supporting us to understand how building fabric upgrades can be included into our model. Does it make sense to be running our heat network at higher temperature with less building fabric upgrades, or a lower temperature with more fabric upgrades? And then following that, we're focusing on the development of our CHG business model. So the business model to help of the unit, which could then help support the development of the community projects and or the operation of them, etc. So what does that look like? We don't know at the moment. Okay. So yeah, we've got a website and newsletter, sign up. So at the link above on the Share Energy website. We've also just started a community a forum on the on Lumio, where the CE forum is. We'd love to be able to engage with you in conversation about what your opinions on and your experience on heat network configurations and what support you think communities need to actually get community heat networks developed. We're not necessarily focusing on community-owned heat networks in rural locations. We're trying to get heat networks developed which have community ownership wherever they are, and perhaps we can get to a stage where if we pick off some of the lower hanging fruit for community-owned heat networks, then some of the more difficult locations might be enabled in the future through the CHDU. Yeah, and we're not sure, it's still early stages of the project, but yeah, I'd love to have any feedback from your experiences, etc. So please get in touch.
Thank you very much for that, Ben. Really, really interesting. Got time for one or two really quick questions if anyone has them. Okay, if not, please do follow up on the links that Ben has put, Ben showed there. I think Richard's put them in the chat, and they are also replicated in the agenda as well. So please do look those up. Thank you very much for that, Ben. Pass
Thanks.
on now to Sydney. You're muted, Sydney.
Right, I'm just looking for my presentation. Oh, where's it disappeared to? Sorry about this. Show all windows, try that, here we are. I think this is it. No, that's not it. Oh, hello. I may need to ask you, Richard, to go through it because it's disappeared from my choice. Sorry, Richard, can you power it up?
Sorry, me, Richard? Is there another Richard here?
Sorry, not Richard. Sorry,
Josh?
Josh indeed.
So, what are you after,
I've
Sydney?
got it on my screen, but somehow when I do share screen, I can't see it.
Okay, one moment.
Hang on. It's appeared. Right. So now we want to do slideshow, don't we? Which would be good if I could see that. Oh, that's disappeared up the top.
Top bar, there's a little picture of a
Here. Can you actually see what I've got there?
hit F5?
F5. Oh, thank you.
Crew pitched up. They'd already put solar PV on the roof. We've then installed things like LED lighting, but most importantly, the building.
F5 has not helped me.
Okay, well, you may need to press your function. If you're on a laptop which needs a FN button pressed with F5, it might need that.
Oh dear, this is. You see, the thing is, the Zoom thing at the top is covering my options to be
I see.
sharing. That's my problem here. And I don't. Hang on, is there anything I can do about that? No. I think it might be better then, Josh, if you just put it up. Apologies for that.
One moment.
Let's go with that. Oh, hang on, there's a thing at the bottom here. Does that help? Oh, hang on. Oh, is that it now?
Yeah, that's good.
Right, okay, let's whiz back to the front. Yeah, so sorry, my name's Sydney Charles, and this is going to be a whistle-stop tour. I was interested in heat zoning following on from an interest in the Edmonton incinerator, and people there are unhappy with having to carry on producing rubbish and also digging up the roads. So we started looking at, well, if they didn't take heat, what would the implication be? And then I started looking at heat zones. So I'll go through these aspects very quickly, and at the end then ask some questions. So, what is a heat zone? Quite difficult to find a picture of it, but I found this one here of, this is a possible sort of heat zone with the barrier around it. And my issue is that if you're not in it, as Sandy mentioned just earlier, if you're not going to be in a heat zone, then they're not really interested. And on average, they're thinking of 18 zones a year, coming to 459 zones by 2049. So, that seems like a long way away, but the definition is a formally designated geographical area in England where heat networks are expected to provide the lowest cost solution for decarbonising heating. But as I said, if you're not in one, then you're not getting any benefit. So, what are the aims of having these heat zones? The primary aim is low carbon heat, which we all agree with, and the consultation asks, well, what is low carbon heat? Can we allow 147 grams of carbon per kilowatt and still call it low carbon? I think most people replied, go with the 44. Now, in the studies that I've done in Enfield, their heat network, they say that it's only 21 grams of CO2 a kilowatt, but they exclude all the infrastructure that you need for the heat network, which seems a bit of a missing out. Secondary aim, of course, is low cost heat, and Ofgem is supposed to be looking at that for consumers. But Enfield in particular will spend at least 100 million to deliver heat compared to just leaving people to do their own heat. Another aim, which is not, it is just stated, heat network zones will also provide project sponsors and developers with a certainty about connections that will be required to secure investments for construction. So enabling heat network industry to be profitable seems to be another aim. It's not actually stated sort of upfront. So which buildings will have to connect? I'll start with what are not required to connect. Ordinary residential buildings with their own heating systems won't have to connect, but they could do. And any building, as we just mentioned, if they're not in a zone, they won't have to connect, leaving them with no sort of government support for low carbon heat. But who will have to connect is new buildings, non-domestic buildings, and buildings that are already communally heated. Now, this one that I've got a picture of here is Enfield Wash, which has got a Kensa ground source heat pump array, paid for, I believe, by the local authority decarbonisation fund. So the capital has been paid for, and they say the customers find it very cheap, but I haven't got evidence of that yet. But the Chartered Institute of Building Surveyors are unhappy with the consultation that it implies that even if a development can demonstrate a lower carbon heating solution, they will still have to connect if they're in a zone. So they're not happy about that. So who would administer this? Central authority will have quite a big department in DESNZ, and there will be zone coordinators in every borough. I mean, you can read what they have to do, but appointing delivery partners is basically giving out the work to commercial companies, which one has to be very careful with, and also requiring owners of heat sources to provide heat, which I know one of the consultation responses from a data centre association was not happy with because various reasons. And they are thinking there'll be 5 full-time staff per zone. Of course, that's up to 2049. Well, I certainly won't be around by then. So what kind of heat are the heat sources they're expecting? They're expecting 18% of it to come from energy from waste, which is why my interest is quite high in incineration. And owners of those sources within the zones may be obliged to actually sell their heat. So, I mean, some heat is in certain places and it's fixed, like waste heat, the picture there of Bun Hill Road, it's getting underground heat, and reservoirs, they don't move, they're there. If you've got homes near them, that's fine. There's also heat in most places. Now, obviously it's different in different places, but generally there's always air, there's always water, there's always something from the ground, possibly geothermal. And that's a picture of a heat network in the City of London, which has got ground source heat pumps, as they call it, going down to the aquifers and heating between the Barbican and the Guildhall. If CE wanted a visit to there, that could be arranged, because I've been on one. That is a very interesting example, showing what can be done. So the heat technologies, which obviously you all know, that's suitable for district and communal energy from waste. This one in the middle is a community centre in London that one of the Community Energy London groups put in, DEFOS. And then there's obviously ground source and thermal. But there's a point here that the closer the heat source is to the customers, the lower carbon, embodied carbon, and actually loss from heat and disruption of long pipes. It's an obvious thing to say, but that came up in Sandy's talk as well, didn't it? That you know, if you've got long pipes, that puts the whole thing up. So, you know, against that is the people left over having their own individual heating systems, still buying gas boilers for quite some time. That's used as a counterfactual to show that in Enfield it's lower carbon to have heat from the incinerator. But then they've gone away from that and said, actually, that was high emissions. Maybe they should be using air source heat pumps. It's all very vague. Another solution for individual homes, and this was written in someone called Chris Twin of Letty, Life After District Heating en route for zero carbon, which sort of says it all, really, that if you've got a mechanical ventilation heat recovery system and very good insulation, actually you don't even need a district heat network. So, you know, something to be considered. And it's also worth mentioning that the air-to-air type will provide cooling, which is increasingly important nowadays. So who are the stakeholders here? Well, customers really should be the main stakeholders, but I've got the planet at the bottom as well, who you can call a stakeholder. And the people who actually know what they're talking about, what the options are, people such as yourself, architects, build professionals, and of course, communities. So their voice and their ideas should be paramount. Right. So who would pay and who would profit is an interesting question. Now, the impact assessment for the heat learning consultation said that the whole thing will cost £10 billion over 40 years, I think it is. And it said it would save £17.630 million, that's 17 billion, based on reductions in carbon emissions and air quality, which just really illustrates how important it is to make sure you're confident about those carbon savings, because 17 billion is a big figure to hang around and hang the whole project on. So who's paying back? The 10 billion cost will be paid back in customer standing charges and heat usage charges, and also taxpayers' subsidies, because it's not clear who's going to be paying out this 10 billion, but it tends to come through grants and loans. And who is liable for any profits? Who has to pay back the losses? The heat network owning companies, the heat network managing companies, and taxpayers. In the case of Enfield, that owning and managing company is Energetech, which is owned by Enfield Council. So all of that, any losses there come back to local taxpayers.
Like a 5-minute warning, Sydney.
Okay, thank you. I think maybe okay. So the impact assessment on capital is, this is from the assessment, that the costs are expected to be lower. They can be lower. There may be net savings, and the costs to customers will be lower because heat networks pay fuel on commercial tariffs. That's in the assessment, but finding evidence behind it is not easy. So a very quick whistle stop of Enfield. They've received about 100 million in grants and loans, Public Works Loan Board and HNIP and the Mayor, etc., that will have to be paid back. But the money they got was actually for the green and yellow lines of pipes. The green ones they're putting in, the yellow ones they've had to wait for reassessment because it looks as though they spent the money, they haven't got any more. So the impact assessment on the consultation, first of all, they had one for stakeholders with a low carbon option, sort of similar to the Chris Twin one, of a low carbon counterfactual. They didn't actually use that then in the consultation. And for the impact assessment, they, hang on. So that is how much is being, it costs. So just some statements from the Chartered Institute, and they are saying how important it is to be on the basis of evidence and justified carbon accounting. This is a page of the calculations I've done, that if we didn't take any heat, then we would lose some offsets, 39,000 tonnes a year. But if we then brought in the extra cost of having the heat network, the infrastructure, that would cost 71,000 tonnes a year. I've put that warning on because, quite frankly, the figures I've been given are, I call dodgy. And my point here is that it's important to have sound carbon calculations, and what I'm seeing is not sound. So yeah, in the impact assessment, they did a theory of change thing with a weighting of 50 for achieving policy objectives, which was low carbon and low cost. So again, you know, if the facts behind the low carbon and low cost are not sound, then that was not a good decision. And they ignored the policy, the novelty policy proposals, which I think was mentioned earlier about the importance of electricity and gas balancing, and general support from the government, which was low weighting, so you know none of that got considered. So the opportunities for communities, well, you all well know that, so I won't talk any more about that. And I'm quoting Share Energy there, by the way. So the next steps are the recommendations go to the ministers. They do a mapping exercise, which is absolutely needed to identify potential heat networks. That would help you, Ben, wouldn't it, if there was a very good mapping exercise on that. And then they'll appoint the zone coordinators and they'll start work between now and 2049. I've put in this extra step of what if we have a new government? Could they review the recommendations in light of their priorities? And certainly, could they review the methodology of making the important low carbon claims? So I'll leave you with these questions. Well, obviously, come back to me on anything. So these are the things that need to be considered, and I'm not coming up with answers of them. Could that £10 billion be better used? Which technologies are low carbon? And I think it sounds as though work is being done on that by what Ben's doing. Is it fair on customers? Is it fair on the owners of heat? Could that number of civil servants be better used? For instance, maybe making electricity connectivity, grid connectivity better. And are the risks to the government acceptable? And that's to do with public upset if it comes to pass and they see it as unfair, which was ignored in the impact assessment. So that's come to an end of it. And thank you very much for listening. And any questions, I shall stop sharing.
Thank you very much, Sydney. I'm very sorry, but we're at time, so we're not going to be able to have questions directly in this meeting. But I think people have your email address, Sydney. If they don't, please put it in the chat. Please do follow up this conversation. I'm fairly sure this isn't the last time we're going to be discussing heat networks in this group. So, but please do continue the conversation here on Lumio via email as well. Last call to please remember to share the heat network, heat and retrofit coordinator role among your networks. We'd really like to get some good applicants to that. Before we finish, does anyone have any quick AOB?
Can I jump in with a quick plea that in the chat is always incredibly rich. Is there any way in which you can just clip the entire chat and chuck it into an email around to everybody?
What I'll do is I'll put it in the notes. So I'll circulate the agenda around again after this meeting, and so you'll have access to it. Yeah.
Fabulous. Really useful meeting. Thanks.
Great, thank you, Chris. And thank you very much to everyone who presented today. Please do send me copies of the slides and I will circulate them around as well, and there'll be a recording going out as well. Thanks very much, everyone. Cheers, see you next time.